the data on the web is unstructured. Like that, there is no specific pattern is allowed that how we are presenting the data over the web pages. Every website implementer has followed its own structure for presenting the data onto the web pages, and of course this is the very useful characteristic that web is dynamic. Every time we are getting a new content for a particular search, we are going to search on the internet. So data is rapidly and dynamically changing every time. So the basic web content mining tasks which are considered are that resource mining is the number one, that from where we are trying to retrieve the information, or whether they are the online or the offline process, and then only we can apply our data mining technique like classification, clustering for extraction of the information. In case of the web mining, information selection and pre-processing is dealt with the web page representation. That basically how the data is presented on the web page is a different matter, and for that pre-processing is required whenever we want to mine the data or the content from that web page. There are several features are available for mining the content from these web pages. There is another content mining task is latent semantic indexing, that determines the cluster of co-occurring keywords so that the query which uses a particular keyword can then retrieve a document perhaps not containing the keyword. This is what we are saying, that the keyword based searching or referring to the web page. Then generalization is that what pattern or evaluation phase where machine learning process is used to identify general pattern in the individual web pages or across multiple web sites. Then there is the analysis phase, and finally there is a presentation or visualization phase of the mined data from the web page. So to go further in this work, there are the motivation that where is the biggest ever data source containing every kind of data. Volume of data increasing rapidly over the internet. Techniques for web mining are not standing before the challenges posed by enormous amount of data. This is very critical motivation that whatever the work we will do, and it will not stand with the amount of data which is available over the internet, and because it is day by day again increasing in nature. Now to limit it somewhere, I have used the concept of personalized content mining. Personalized content mining is as per the user interest, likes or dislike, so that instead of covering all the scope of the various data available, now I am going to cover the limited data as per the likes or dislike of the user. This is what the unsupervised automated web content mining for, and the data which we are getting will be available for further machine processing tasks directly, which will be available in the form of a local database table. So I have done the literature review for the structured data, semi-structured data and structured data. My target work is in the area of structured data extraction. To understand better what is structured data, the data usually retrieved from the back-end databases. That we can say that when the dynamic web pages are created, they are the result of the query fired by a user, and those web pages are implemented during that runtime, and the data are actually accessed from the web databases. Like whenever we are going for any website, like commercial website like Amazon.com, and we are searching for a particular mobile phone as per our needs, the data is retrieved at the real time from those web databases. The displayed in the web page following some fixed template. Now this fixed template is like that's how the data is actually presented when at the time of its implementation. So generally it has a fixed template. Moreover, this fixed template of data presentation for structured data is generally considered the visual appearance of the human being, that it is centrally located on the web page. Then there is a kind of semi-structured data. This is some way to, each page is organized in some way to some extent, usually as a hierarchy of blocks, or that is from web pages. And the finally is unstructured data. that is a kind of free text or natural text is available. It may have the multimedia data and receive less attention than text or hypertext pages. Unstructured data mining, because as it is said that it is basically covers the free text, so it goes to the basically part of text mining or natural language processing. So I have done this structured data extraction literature review. The technique.
You come to what are your new conclusions?
Okay.
Which soft computing approach you have applied in this?
Yes.
All these things.
So after those literature review part, I am going with the what are the problems in current approaches. So after literature review, there are the various problems in current approaches are available. That is poor post-retrieval content analysis. This can be possible at client-side web computing. Then individual search sessions are considered for information retrieval. No search session sharing is done because every user are doing the content mining as per their need, and no number of users are their sessions are not maintained. Maybe possible that many users have tries to mine the content for the similar kind of web data. Then wrapper is an IE system customized for a particular website. Now we cannot do the content mining for a particular website. Instead, we have to cover the entire internet for content mining. So of course the wrapper system is such a system which is mining the data from a particular website. Source documents are designed for people and few sites, provide machine readable specification. So after all this, there are the research needs are evolved, and which I have question for number one: how to achieve full unsupervised yet efficient and more effective structured web content mining. Then how to decide what data to be extracted from the web table of the web page and in what format. Then how to mine the data from various web pages of several websites which possesses different design template implementation strategy, because somebody are trying to implement the web page by simple HTML, somebody are trying to use the PHP or any other programming language mechanism. So in spite of all these, there should be a language independent scenario for web content mining must be available. Then how to achieve the full freedom of deciding the factors such as mapping the attribute among the user profile in the database versus web page table attribute, because we are talking here about personalization of the content mining part. Then how to solve the problem of alignment of data record and the data item, because every time if we are looking at the single web page, it possesses HTML tree which is said as the document object model tree. Then there are the many data region or data record and data items are present. So alignment is a very big problem there. Then only we can go for the efficient web data mining. Then how to make the system more robust for any kind of data presented on the web page and processing the large volume of web page. So of course over the internet we may find that enormous numbers of web pages. So we have to build such a system that it can mine the data very effectively and efficiently. Then how to overcome to unify the problem of language used for implementing the web page. So based on this, I have decided the objective and scope that developing a solution for personalized web content mining, then making a more robust system which can extract structured data from these web pages. Now these web pages, here I am using the dynamic web pages as the deep web pages, because deep web pages are built as the result of the query fired by the user to the web databases which is attached to the internet. Then making a universal solution for web content mining so that the data published by various web databases can be extracted out by reaching to several websites, processing millions of web pages. Then there should be a objective like automating an unsupervised mapping of attributes. Then to make this available, available the mine data for further machine processing tasks or for applying traditional data mining technique. Once that database is available with me, then I can apply any kind of data mining technique, or I can mine any other knowledge if possible. So in this case, my research contributions are, I have done on the work that is automatic web content mining technique, automatic conversion of web page content to the relation in a local database to enable further machine processing part. A personalized web content mining system is developed against the user specific likes, dislikes using user profile. There is implementation of key means clustering algorithm for automatic mapping of attributes of web table to relation in a database. The approach is domain independent, programming language independent used for the web-based design, and it is scalable. So I am not considering any specific domain for mining the content. So based on this, the problem statement is, in view of the above observation and from the review of current literature, it is proposed to investigate the following: analyzing the existing web content mining technique, then developing a new method for personalized web content mining, and then implementation and evaluation of proposed new method for personalized web content mining. This is what the overall system architecture which I have followed, that directly we are accessing the web pages from the internet, then it is going to the structured web data extraction system, then web page content is there for multiple relation. Then at the attribute level classifier, for each relation I am using the user interest tuple, which is again utilizing this user profile. Then context mapping, row column aligner and redundancy check is there. And finally, the result is stored in a local database system. This is how the basic work can be presented, that raw crawled web pages are getting converted to a personalized recovered table in a local database. So structured content mining from deep web pages is a large amount of information on the web page is contained in regularly structured data object. So basically it means that many of the implementer of the website, they are putting on a web page, that is a web table is there, image is there, then free text also available, but most of the data is available in the form of some structured data. Such web data records are important because they often present the essential information of their host pages, that is like list of products and services. Then applications are like integrated and value-added services are available there. So like comparative shopping, meta search and query, etc. This is how the example web pages can appear on a particular website like Amazon.com. If you are searching for a books category, so we can get such a kind of data presented over the web page. Now in this case, there are the various kind of noise information also available which we are not interested in. So we want to only seek or mine the content like what is the book title, its ISBN number, its cost, author name and all that. Because if you will see it is generally presented in the center of the web page. So while content mining task, we have to remove the noises and we have only focus on the main content of the web pages which is displayed over. Then web pages may contain the data table in this form. We can see that this is the kind of structured data available on the web page. And this is how the system is actually working, that starting from inputting a web page to till the data table. In this case, we are starting with building the DOM tree of the web page available. Then in that DOM tree, we are identifying the data region. In a particular data region, we are identifying the record, and each record may have the several items. So we are here going for multi-data region deep web pages, and many of the work has been done in the area of single data region deep web pages. So if only we are considering single data region deep web pages, then it may be possible that we are missing out more useful information from the same web page. So multi-data region deep web pages is the good one, so that we can mine the most useful and altogether good number of data from that web pages. So building HTML tag tree, for that we are using the Nico HTML parser library or the Nico HTML tool. Now, when any web pages get loaded onto the browser window, the browser works in background, and that browser represent that web page in a HTML code only, and we have to scan or pass the code to get the HTML tag tree. This is what a kind of HTML code may be appearing over for a particular web page. Now, thereafter, we need to determine the multiple data region of the deep web page. So we cannot go for directly mining the data record directly, which is hard, and which so we need to first mine the data region. By comparing tag string of individual nodes and combination of multiple adjacent nodes, we can find each data region. So may be possible that in the body of this HTML tag tree, there is a data region available, there may be more data region available. So we have to reach that particular data region by parsing technique. This is how the overall scenario of a data region may be available in a HTML code, that there is a node starting from that one is representing the HTML tag, and thereafter there are several other nodes which I have numbered in. Now the grouping of region 1, region 2 and region 3 I have done, and this basically region 1 is giving you the information for a particular kind of information for particular product, or similar kind of information is accumulated in the region 1, similarly for region 2 and region 3. So this is how the multiple data region deep web pages is generally having the HTML code structure. Now in this case we again have a general case diagram for the data region. So in case of determining the multiple data region of the deep web pages, there is a concept of generalized node. A generalized node or a node combination of length R consists of R, which is greater than or equal to 1 node in the HTML tag tree with the following two properties, that all the nodes have the same parent and nodes are adjacent, meaning that we have to reach to that particular parent in that tag tree, and once that we are reaching to that parent node in the tag tree page, we can, as a whole, we can mine that particular content. So data region is a collection of two or more generalized nodes with the following properties, that the generalized nodes all have the same parent, all have the same length, and the nodes are all adjacent. So these are the basic properties that we were getting help of to find the data region. So after identifying the data records within each data region, we need to go for this data record identification. After all data regions are identified, we identify data records from the generalized node. Now, may be possible that the data records are the number of subtree, and this subtree may be containing data items. So, a particular data region is again a very big tree to process out. Then there are the two different scenarios of data records may be possible, that non-contiguous data record, that is case 1, and this is contiguous data record and non-contiguous data record. So that is by mistake there. So in case of the continuous data record, the sequence of items are appearing one by one. While in case of the non-contiguous data record, there may be a possibility of that the sequence is broken by some additional addition of some information which is not relevant in our case. So data extraction is basically based on this tree alignment technique, or simply a tree matching process. In this case, the tree general tree mapping example I have given here, that how two trees are matched with their node-to-node representation. This is how the actually input web page is there for a particular from a particular website, and when we are going for the experimentation, we are getting for that particular web page we are getting this kind of output. See here, that table number 5, meaning is that there are table 4, 3, 2, 1, and the number of tables are there. So all that web pages is there constructed in the form of structured data. Now the listing of tables are very large in number, and out of those number of tables we need to identify the actual table which is containing the main content. This is another example. Now to get the main content data table from the web page, I am going for the DOM intersection method concept. In this case, what I am doing, that I am considering the dynamic web page with a query string 1, dynamic web page again with query string 2 from a similar website. Now the similar website will always follow the same kind of structure for data presentation. So I am going to subtract it, or their trees are getting subtracted. So what will be removed? The only common information will be removed and the uncommon information will be available. So I will get the noise-free HTML, and that is available for further processing. In this case, for a particular website type, I will form the wrapper, which is a rule, so that if I want to mine the data in future from the same website, I will, instead of doing that processing, I will apply the wrapper rules. So from the previous one, this is how the tables were there. Now this is what the page with the query string 2, and this is what the result is.
These are the implementation of already existing techniques. Wrapper extraction and this tree matching, these are already existing in literature.
Sir, I am going further for the personalization part.
These are all implementations.
Sir, I am going for the personalization part, that is personalized web content mining. From this part onwards, because sir, getting that platform working for doing the experimentation is a big job in this case. So we have got the content available. Now in my case I am going for the personalized web content mining using the soft computing technique. In this case I am going for the DOM tree creation first, then for converting the web page content to the structured form. That is what I have done.
What soft computing technique you are using?
Sir, here I am going for the statistical k-means clustering approach.
This clustering is not at all soft computing. Please, you try to realize that k-means cluster analysis is prevailing there since 1940s, 1965. McQueen first did this formulation. But k-means clustering is an unsupervised learning algorithm. It is no way related to soft computing. Anyway, fuzzy ceilings is a soft computing version of k-means.
Yes.
Okay, go on.
Actually, sir, I have done one experimentation with the
k-means based categorization of web documents is a web documents or mapping documents into web attributes.
No, sir, I am going for the mapping of attributes of the user.
This is something new. I think there are a lot of papers on in this direction. Anyway, go on. Let me see.
Sir, for that, this k-means clustering I am using for the mapping of the attributes of the web table with the user interest. Like this is what the user interest.
Means you are kind of extracting relations from the web tables to create local database kind of stuff. Isn't that?
Yes, yes.
For that you are using k-means clustering.
For that I have already I have given this number of relations which are fixed in nature, because if I want to ask every user to give their choices, so accommodating those at the runtime is not possible. So what I have done that.
Then there comes another question: how you are fixing the number of clusters key? Because such user number can be infinitely many in different social services.
Each relation here will be the big cluster, and each attributes of that relation will be the subcluster in that. So now that subclustering are getting populated at the randomly by means of the k-means algorithm. So now we can see that the computer is the one relation. So here I have given 4 different attributes, and each of these attributes are getting populated automatically. Once they are populated or till the web table contents are over, then it is saved to my local databases. Now we can apply the same operation with other web page of the other website. Likewise, if the user interest is like in books, car, TV, or I have given total this 8 such relation. So they are getting automatically search over this column name and their attributes. Cluster will get populated, and finally I am storing those data in a local database. This is how the example of this book relation is there. Like on a web page, such a kind of information is available. So finally I am getting my system is updated with this kind of data that is what, that is C1 representing the column 1 in my relation, C2, C3, C4 up to C8. But if we see that this kind of web page containing many other information which I am totally removing. Likewise, this dot represents this particular web table, local table will be utilized whenever there is the occurrence of book relation information available from any such web pages. This is how the attribute mapping is done between the user interface profiler versus the web table. That is C1, that is column 1 is mapped is going for the auto generated number field value, because every time this is what I am getting populated automatically by increasing it by 1. Then C3 is going with the C2. So this kind of column aligner part and populating the data is what the personalization in this case we call. So now this result analysis, most of the all the works are generally measured on this recall and precision over here. That is EC by NT gives the recall and EC by AT gives the precision. So this is the data set. Earlier in the reference paper, I have seen that the complete planet.com is the repository which actually gives the 43 different categories of web databases, and we can mine the web pages from those complete planet.com in whatever the category we want. But since last 2 years, this particular website has gone off from the internet. But in many of the
from you are taking these 2000 deep web pages from various sources. You are not using KD Nugget, the KDD cup data actually. This SEM KDD, they have a web page. They maintain a list of such many web pages. As you are saying, Complete Planet has gone off because of KD Nugget probably. Have you seen that?
I have seen, sir. Then because I was only first of all relying on this Complete Planet. Then according to my work, that the kind of web pages I am working on, it can be obtained from any particular website. Because many other work which has been done earlier, they are specifically finding for such a web pages, like having single data region or very simple HTML web pages only. But now the web pages are very complex in nature, so there is no limit that from where we can get the data. Otherwise, the Complete Planet about the good source of the such data sets available. So that is how I have gathered the 2000 deep web pages from the various sources available on the internet. So in such cases, this my structure content analysis part here I am giving for total 95 web pages, and I am comparing with the white RE. This is white data vision based data record extraction system, and MDR, that is mining data region. Mining data region and RE, these are the two established systems in this case. So the recall and precision I have calculated based on the number of correctly extracted record, that is EC, based on the average total number of record extracted and total number of records available on the web. So this is for structure content mining. Then for personalization, I am going for 3 different websites that I am going to collect the web pages from the phonecurry.com, Amazon, Optius.com for these 4 different kinds of categories of data, that is for mobile, TV, notebook and digital camera. So I have given the total number of web pages I have scanned from each of these websites. So since the phonecurry.com is only providing the data for either mobile or the tablet, so that is average number of informative block per page, how many are there, this is calculated. Similarly the noise block, and I am getting the precision for informative block and the recall for informative block. The similar result is there for Amazon. Now Amazon can provide the data for mobile, TV, notebook, digital camera and all that. So I have done the similar kind of analysis like this. So here I cannot compare with any other system because no, like BidRE or the MDR, they have not gone for any personalization task. So that is what the need of the day, need of this time, that we have to restrict ourselves that what kind of data we want to mine. So personalization term is generally applicable when we are going for searching over the internet, but when it comes to mine the data, nobody talks about the personalization. So web is a big source of data, and we need to mine our data in a personalized way again. So that is what I have done. So conclusion is that manual structured web data extraction method bring considerable cost to organization, because it's not possible to every time you take the page and then mine or work by pen pencil. So we need to go for automation. For large scale data mining, manual data extraction is tedious. So automatic data extraction method typically a good solution for template generated web pages. Now here template generated web pages, if I am saying, it means that the structure is fixed for the big web pages, and there must be a solution for the fully automatic web scale structured web data extraction. Again, whatever the work we are doing or anybody will do, it will again they require to have to build up the very strong or methodology, because the day by day the volume or the data volume on the internet is increasing, number of databases are attached. So it is demonstrated that the proposed method for extracting structured data record from deep web pages is more effective in terms of precision and recall. The method can also process technologically sophisticated modern web pages, since web pages rendering occur in modern web browser. This is why I am moved to consider any web pages available from the various sources. So the proposed methods are completely unsupervised, automatic and domain independent. So here I am not considering any domain to mine the data. Like many of the work which I have found that they are considering only like car domain or automotive domain or the science technology domain, and then they are doing for the content mining. The future work is like more robust algorithm may be needed to handle the vast amount of data from the web pages. The system can be enhanced in future by considering the maximum number of local database table having numerous fields of attributes. As I have considered only 8 relations with limited number of attributes, so we can we can enhance it by adding more relation and more attributes in the local databases. The system can be easily molded as a recommendation system, opinion mining system, or reviews collection, because what we are doing, we are actually building the database here. So recommendation may be possible once we are having the data available. Opinion can be given once we are having the opinions collected from those web sources or reviews. This is what the publication, 3 journal paper and 2 conference publication.
When from you started this work?
Yes, sir.
When from you started? Let me see your journal publication. First paper arrived in all 3 papers in 2015. So when from you started working?
Sir, earlier I have 2 publications in my conferences. Like this. 2013, 2014.
So you started from 13 mostly?
Not 13, it started from 2011.
Now, looking at your journal publications, once again I can see that you haven't published in any core journals to date. Because this Journal of Computer Engineering, Journal of Computational Engineering Research, these are not, are these journals SCI index, original Thomson Reuters index?
No, sir.
You should have at least one paper in a core journal before submitting the thesis.
Sir, I have not mentioned one paper is accepted at the free journal at Hong Kong. So that is under processing, accepted with some revision. So I have not mentioned that one.
Is that a core journal of transactions?
No, it's not a
ACM transactions on web. That is a core journal dedicated to internet. Similarly, Springer has one of their journals dedicated to personalized web mining and things like that. But these journals are kind of, they can accept everything. They are kind of all pass filters. Okay, forget it. The next question is, in your k-mean study, when you are developing the system for each attribute, I mean like if it is a book or if it is a car or if it is a computer, in every case for k-means clustering you have to give the input of number of clusters. How you are deciding that? This is one question. Another question is how you are measuring the distance between different web pages.
Sir, actually the relation is available in the system, and the structure of that
subcategories like ISSN number of the publisher pages.
So I have fixed those attributes already. Now, if in the system,
for how many things like books, computers?
Yes, I have given this in the slide.
So you have already fixed all these things.
Yes, sir. Serial number, model number, company name, and price.
Computer, book, car, TV.
Yes. So
only 4.
yes, So I have limited this number of attributes for the computer relation. As I said that we can go for increasing the number of attributes, but for experimentation purpose and for the complexity which are arising out of this
How
working.
much time does your system take to extract the data and say, show as a table of comparing one book with another book or one car with another car? How much time does it take?
Sir,
There is no slide on timing complexity issue.
sir, actually this particularly the work which I have done is one is the structure content mining and then personalization task. So in this case, two different way I am working. Like so, getting exactly the execution time for one particular web page processing, I may get it, but this is not relevant to put up that particular time execution required. Because
don't you think if you want to commercialize this system, then people will be interested only if it takes a considerably less amount of time? Like,
yes.
I mean, you know, this kind of web page extraction or table formation recommender system are already available. I mean, so for example, the policybuzzer.com, they immediately extract different policies from different companies' websites and prepare as a list showing the advantages and disadvantages of different policies. So that's why they commercialize it like before buying any policy,
yes,
compare.
So that is for one particular policy domain.
But that takes very less amount of time.
So I
That's
can
why
add.
we can commercialize it.
Yes.
In your case, what is the time?
Sir, I can add that particular time
investigate.
execution. I can add those time execution. So I will add that particular table of various time required for each web page processing. So I can add that.
Then you should add more discussion. I see that your thesis is 122 pages long, out of which 80 pages are gone for introduction, literature review, and conclusion and future direction. So only 42 pages of your work. I think this part should be more enhanced. I mean, your new contributions must be much more emphasized. And the technical issues should be better discussed, like how you are computing the distance in K-means cluster. K-means is a typically slow algorithm because you have to calculate a lot of Euclidean distance.
So actually I have selected that algorithm.
In this case, what kind of distance measure you are using for K-means cluster?
So that is of course the Euclidean distance algorithm I am going to making use of it. The K-means basically selected because it works on the random cluster. So when I have given my all 8 categories of the relation with having different attributes in each them, I don't know that what kind of web pages is coming. So I need to employ such an algorithm that we can start generating generating the cluster randomly.
So what are the features for clustering? I mean, the objects must have some features based on which you will calculate the distance. Here you cannot use, are you using turn frequency kind of feature or what kind of feature do you
When
use?
we are moving to a particular part of the HTML tag tree there,
Yes.
and when we are reaching to the, so I am going for exact string matching with what available in my relation attribute and with what available as the information of that node. Once I get that matching available with me, then I go for further part of that tree to get the attribute information. Once I get one particular attribute, I start generating that cluster. So here exact matching of string I am doing.
That cluster means K-means doesn't do that. K-means starts generating all clusters together, isn't that? I mean, it's a partitive clustering algorithm. And then that does mean your features are kind of categorical since you are doing for string matching, isn't that? So it should be a K-mode algorithm. Why you are talking about K-means I don't. Anyway, that part is, you should investigate it better. Whether it is actually categorical data. It's processing the categorical data. That's why it should be called as K-mode algorithm. Anyway, thank you for your presentation.